let us evaluate an integral regarding rational fractions, specifically one that contains a repeated linear factor. Now, whenever you encounter something like this is generally the formula for it. So, the integral of p of x regards to any numerator over these repeated linear factors, which we will represent it as a minus x minus a, wherein a here is the constant, and so this should be raised to the power of n of dx. So this should be equal to the integral of a constant, let's say something like a sub 1 over x minus a plus the integral of a sub 2 over x minus a raised to the power of 2. Basically, the exponent will add 1 by 1 until it reaches the exponent of n here. A sub raised to the power of n. And so, in our case, we will have an x minus 3 raised to the power of 2. And so, we can now rewrite this. So, first up, let us focus on the factor of x minus 1 first, because that seems simpler. So, this would be a over x minus 1. And so, we can now focus on the repeated linear factor, which we will call it as b, which represents a sub 1, over x minus a here refers to x minus 3, plus a sub 2 here will represent as c over x minus 3, and so we will add 1 to the exponent, so this would be 2. And now you can see here, 2 here is our exponent, so we will stop at this limit. And so, by the way, we will not be putting first our integral nor the dx here for simplification, these two. And so, now that we have our rewritten form here, let us equate this to the problem itself. So this would be 3x squared minus 13x plus 14 over x minus 3 raised to the power of 2 multiplied by x minus 1. The next step would be to eliminate the denominators on this side. So multiply this upon this. So this would be x minus 3 squared multiplied by x minus 1. And so multiply it on all these given values. And so copy what's rest here, which is simply 3x squared minus 13x plus 14. Now, multiply these given values on this first part first. You can actually see when you multiply it, x minus 1 would cancel, which leave you with a multiplied by x minus 3 squared. And so, focus on the second part. So, you can see that x minus 3 here will take 1 x minus 3. So, this leaves it as b multiplied by x minus 3 multiplied by x minus 1. And so, focus on the third part. You can see here that x minus 3 squared will cancel, leaving you with c multiplied by x minus 1. Now that we have that, just copy the rest. So this should be important later on. By the way, just a reminder, this is the factored form earlier, which is a over x minus 1 plus b over x minus 3 plus c over x minus 3 squared. This is the same as that. So our objective here would be to get the value of a, b, and c now. So let me just rewrite. So in order to get the values of a, b, c, let us make use of the two factors here on the denominator. Let us focus on x minus 1 first. So x minus 1, let's equate this to 0. And so transposing 1 to the other side, we have a value of x minus 1. And so we need to substitute all x values here as 1. So this would be a multiplied by 1 minus 3 squared plus b multiplied by 1 minus 3 multiplied by 1 minus 1. And the rest, x minus 1 would be 1 minus 1 equal to 3 multiplied by 1 squared minus 13 times 1 plus 14. So let us calculate. You can see 1 minus 1 here would 0. And so anything that is multiplied by 0 is 0. So this should be all equal to 0. Including also this. 1 minus 1 is 0. And so what you are left with here is 1 minus 3 is negative 2. Equal to 1 squared is simply 1. Multiply that by 3 would be 3 minus 13 plus 14. Negative 2 on a parenthesis squared is positive 4a equal to 3 minus 13 plus, this should be 14, is equal to 4. So dividing both sides by 4, you have a value of a equal to 1. And so we have our a value now. Let us focus on using the second factor next. So the second factor that we will be using would be x minus 3. No need to mind the exponent first. Just focus on x minus 3. So equating this to 0, putting 3 to the other side, we would have a value of x equal to 3. So substituting every x here as 3. So let us simplify it. 3 minus 3 would be equal to 0. Anything that is multiplied by 0 is simply 0. And also this 3 minus 3 would be 0. So anything here is 0 now. And so what you are left with here would be c multiplied by 3 minus 1 is 2. So this would be c multiplied by 2 or 2c equal to 3 squared is 9 multiplied by 3 would be 27 minus 13 multiplied by 3 would be 39 plus 14. And so 2c right here would be equal to simply 2. So divide both sides by 2. You would have a value of c equal to 1 also. Now, we cannot use the factor of x minus 3 raised to the power of 2 because that is not possible in our case. And so, what we're going to actually do here is to use the values of a and c. Since we already have values on a and c here, we only need to substitute a value of x in order to get b here. So, the method that we will actually use here is to get any values of x that we would want. x here can be 1, 2, 3, 4, 5, any number that you would want. But what I would want to put x here is equal to 0. So let us substitute now. So a here is equal to 1 multiplied by x here is 0 once again as our basis, plus b, let us highlight it so you would know what our missing value, multiplied by x minus 3 multiplied by x minus 1, plus c here is equal to 1 multiplied by 0 minus 1, and copy the rest while substituting x as 0. So 0 minus 3 is simply negative 3. Square that, it would be positive 9, plus b multiplied by 0 minus 3 would be simply negative 3. 0 minus 1 is negative 1. Multiply these two together, you would have a value of positive 3. Plus 0 minus 1 is simply negative 1. Multiply that by 1 is simply negative 1. Equal to 0 squared is 0. 13 multiplied by 0 is 0, which leave you with 14. So negative 1 plus 9 is simply positive 8 equal to, plus 3 multiplied by b is 3b equal to 14. So transposing 8 to the other side, this would be 3b equal to 14 minus 8. 14 minus 8 is equal to 6. And so divide both sides by 6, by 3 b here would be equal to simply 2. So remember that this whole integral is also another form of this because we just made this. So we can now actually put the integral side here. So this would be a over x minus 1 plus b over x minus 3 plus c over x minus 3 squared of multiplied by dx. And so since we already have our value of a, b, c, let us substitute it. A here is 1, b here is 2, and c here is 1. We can now actually integrate this one by one. But first, let us split it up. So this would be the integral of 1 minus x minus 1 of dx plus the integral of 2 over x minus 3 of dx plus the integral of 1 over x minus 3 squared of dx. And so you can put any constant outside the integral. So you can put 2 outside. It is not necessary to put 1 because 1 multiplied by integral of the value is simply an integral. So rewriting this, you can actually multiply dx in here. So this would be the integral of dx over x minus 1 plus, since you already put 2 here, this would be 2 integral of 1 over x minus 3 of dx. So you can actually multiply dx here again, which leaves you with dx over x minus 3 plus the integral of dx over x minus 3 squared. And so let us focus on this first part of integral, the integral of dx over x minus 1. So let us use u substitution here. So let u here be the values in here, which is x minus 1. And so when using u substitution, take the derivative next step. So the derivative of x is simply 1. And the derivative of negative 1 is 0 because it is a constant. And so multiply it by dx. So you can actually see here that du is equal to dx. So this should be the integral of du, because substitute dx is equal to du over x minus 1 is u. So the integral of du over u. So why did we put it in that form? Because of this logarithmic formula for integral. Know that the integral of dx over x is equal to the natural log of absolute value of x plus c. So it is the same as this but just a different variable. So by that, the integral of du over u is simply the natural log of absolute value of u. No need to put plus c yet because remember we have other parts to solve integral. And so putting u back into the original form, which is x minus 1. So this is simply x minus 1. Now that we have our integral for this, focus on the second part. Which is the integral of dx over x minus 3. And so let u here once again be x minus 3. So take the derivative. Derivative of x is 1. Derivative of negative 3 is 0. And multiply that by dx. So you can see here again, du here is equal to dx. Substituting that, this would be du over u. We have reached the same situation again as our first part. So this would be plus, copy the 2. So this would be 2 multiplied by the integral of this, which is the natural log of absolute value of u. So u here is x minus 3. So replacing that, this would be x minus 3. And so next, for this, since it has an exponent, it is a sign that you don't need to use this because you can actually put it around the numerator. So this would be the integral of x minus 3. And so when you put it on the other side, the exponent here would change. So this would be negative 2 of dx. The reason that we can do this with an exponent, because remember, whenever you don't have an exponent, it is always equal to 1. And so whenever you put that, this would be the integral of x minus 3 raised to the power of negative 1. You cannot integrate something that has a power of negative 1 because of power rule limitations. Now that you have that, you can now use u substitution in here once again. So you can actually see that x minus 3 is equal to u here. And so take the derivative, this would be du over dx. So rewriting that again, this would be u raised to the power of negative 2 of du. And so you can simply take the integral of this using power rule. Know that the power rule would be u to the power of n would be equal to u to the power of n plus 1 over n plus 1. So when you have a something like u to the power of negative 1, this would be u to the power of negative 1 plus 1 over negative 1 plus 1, which is equal to the division of 0 and u to the power of 0. So that is why you cannot put something like that or have an integral that has a power of negative 1. So in our case, we have a negative 2. Negative 2 plus 1 would be negative 1 over negative 1 plus c. And so negative 1, this makes the fraction negative. So this would be negative u to the power of 1, power of negative 1. We can actually put that to the denominator, which makes the exponent positive. So this should be 1 over u here, u to the power of 1, or u here is equal to x minus 3 plus c. And so this should be your final answer.